Hi friends, welcome to follow up. Let's have a look at problem 2364, count number of band pairs. So in this video, we're going to explain how to reduce or transform the problem and use data structure to solve the problem. So here we are given an integer array called nums, and a pair of indices, say ij, is a bad pair if they have an order and the difference of the indices does not equal to the difference of the numbers. So we are required to return the total number of band pairs in nums. So here we have two examples. In the second example, so we're going to return 0, because if you look at the index and the corresponding numbers, because this one is incremented by 1 each time, and the indices are also incremented by 1. So all the pairs are not bad, right? So we are going to return 0. In the first example, the output is 5, and so they actually specified the bad pairs. So before we do the analysis, let's look at the constraints. So the numbers list can have a length as long as 10 to the power 5. So this length basically tells us that we need to work on algorithms that is less than, say, in square, for example. So because a typical computer, so they can treat 10 to the power 7 operations per second all around. So here the elements in the list is strictly positive. It's greater than or equal to 1 and bounded above by a large number. So with that said, let's look at the problem logic. So here I would say the coding is not that demanding for this problem, but the casing is the logic. So here let's first analyze the bad pair, right? So bad pair condition. So the bad pair condition basically said that, let's see, we can call this nums in the list A, right? So let's call this one A, right? So j minus I does not equal to nums to aj minus ai, right? So in this format, so we know that both sets involve I and j simultaneously. But if we transform this, basically this is the equivalent, right? So it's j minus aj does not equal to I minus ai, right? Or reverse, you can use aj minus j and ai minus I, right? So these are the corresponding bad pairs. So let's use the terminology that if a pair is not bad, it's a good one. So then actually assume the length of A is say n, right? So in total there are say n choose 2 pairs, right? N times n minus 1 into the division by 2, right? Then if we could find all the good pairs, so we can, the result or the return would be the number of all pairs minus the good pairs. So for good pairs, basically it means that this will be equal, right? Right. So then what we can do, actually we can use this difference as k, right? And we count the frequency of this difference by scanning the list. Then we can compute the number of good pairs, right? For example, if a index, let's see, use nums this one as a example. So we have the indices 0, 1, and 2, and 3, and then we count the index minus the number. So the first one is -4, right? It appears once, right? The second one is 0, so it appears once for now. Then 2 minus 3 is -1, so it appears once. And 3 minus 3 is 0, so it appears again. So in other words, so this appears twice. So this is the the store or dictionary information, and then the total number of pairs is choose 2 out of 4. That is 6, right? And then the good pairs. So because we have this is greater than 1, then we have 2, right? 2 is corresponding to 2 indices. It corresponding to 1 pair. So in other words, so we want to minus this. We use 6, the total, minus C2, choose 2. That is 1. So we get 6 minus 1 equals 5. So this actually also finishes the analysis for example 1, or finish the digest for example 1. So with that said, basically writing the solution or a solution for this problem is rather straightforward. So here we're going to let's see, we're going to initialize a dictionary. Let's see, we have this one, and then we're going to iterate this or scan this list. So here the index comes into play explicitly. So we're going to do this for I, Y in enumerate A, right? So what we want to do is we want to use this key, I minus Y. Or you can use Y minus I, the same, right? You just add a negative sign in both sides. But you just need to use them or use the convention consistently. So we want to update this key. So it's going to be D, get the occurrence of this key in the dictionary. And then if it does not exist in the dictionary, the frequency will be 0, right? Then we can add this one. So after this scan, so actually we get this kind of information, right? Then we just need to do the return. So basically, let me first get the good pairs, right? So good pairs, if for a k it corresponding to multi-indices, we need to choose 2 from those occurrences of indices. So basically, we want to do a sum for v, choose 2, that is v times v minus 1 over 2 for v in the values. So here we can use filter, for example, if v is greater than 1, right? Or it does not matter, because if v equals 1, it actually yields 0. But now let's use this one. Then what we want to do, we just return all the pairs, that is length A times length A over 2, then minus the good pairs. So we are going to get the desired count for bad pairs. So that's actually a solution to this problem. So actually it can be very short, right? So before we make any further comments, let's first do a test. So here it's wrong. Let me see where is the problem. So here we have IY in the numerator A, right? And then we get IY 0 plus 1, and we for V in D values, if yes, so let's ignore this. Let's see. What's the problem? Let's see. D for I, D I minus Y equals, get this one, count plus 1 for D values. Then, oh, so here we didn't minus 1, right? So we compute the count, choose 2, right? So the length A minus so here let's test. Yeah, it passes the example 1. Now let's look at the generic case. Yeah, it passes all the generic cases. If you like, or if you want to be rigorous, so you can add a filter, right? It's still the same. Yeah, that's about it. So with that said, basically that's about it for this problem. So overall, this problem provides another example that for us to use data structure to solve the problem. And in between, so we regard that it's important to transform the problem to a format that is easy to be digested, right? So with that said, that's about it for this video. Thank you.